Hello everyone, from Math 1435, that's Pre-Calculus 2. It's Professor Wenson here again with a video on your KnewtonAlta homework for section 8.1, part 3. Graph sine and cosine functions. Now if you watched my last video on 8.1 part 2, you've already seen me do this, so I'm going to go through the same several steps, same 5 steps that I like going through with these key values and whatnot. I'll call it the key value method. Or you could, follow the procedure that's offered by Newton as well. Both work. I think theirs is a little more complicated, to be honest, than it needs to be. But that's just my opinion. All right, if you like it better, great. All right, so here it is. Now, the first objective, there are two of them. One is find the equation of a sinusoidal function, right? A sine or cosine graph, a sine or a cosine function, given a graph. And then the other one is, the other way around. The other objective is, if you're given an equation, can you draw the graph? All right. And I've done the graphing in section 8.1 part 2's video. Pardon me. And I'm going to follow the same exact steps I did there here. If you want, you can click on more instruction, all right, and look at how they suggest you make graphs and whatnot. I'm not going to do that. All right, I'm going to do the way I feel comfortable with, and and you decide which one you like better, their instruction or mine, and go from there. Okay, so let's look at this first one. We're asked to find the equation of the graph given below. Notice that the sine function is used in the answer template, right, down here. So they have sine. So you're filling in the number before, the expression inside the sine, and a number after if it's added. So it's representing a sine function that is shifted and or reflected. Use the variable x in your equation rather than the multiplication symbol. All right. So look at this graph. Now, they're showing us one full period here, right? From starting at x equals negative pi over 2, and then you see the graph, the wave goes, and then it starts repeating after 3 pi over 2. So the period, right, and I'll draw this up actually and show you on a piece of paper. Okay, so I've drawn that one cycle that they pointed out, where they had the little dotted line, going from here to here, showing that that's one period of the function, one cycle. So the period, remember, is how long it takes for the graph to start repeating itself. So the period of this particular function is 3 pi over 2 minus negative pi over 2. How far apart are those from the beginning of this cycle to the end of the cycle? Well, that's just 3 pi over 2 plus pi over 2. That'd be 4 pi over 2, which reduces to 2 pi. All right, so it has the same period that the sine of x does. All right. And remember, they want us to make a sine. Now recall what the sine of x looks like. All right, just y equals plain old sine of x. Remember, that starts off at 0, 0 and goes up, then down, then up again, and then you got 2 pi as the period. All right, so this has the same period, and this point here is negative pi over 2 comma 2. So if you were to look at how did things get shifted, the start of normal sine is at 0, 0. So there's a shift left pi over 2 and up 2, right? Left pi over 2 from the origin and then up 2 to get to the beginning of this cycle. Right. So remember what we're trying to draw here. Y equals some number times the sine of, and then some expression inside, say bx plus c and then afterwards plus some d. I would rather think of it this way though, right, to keep the transformations and easy to keep track of. I'll think of y equals, remember this number on the outside will affect the amplitude times the sine of, and then I'm going to rewrite this here in a different way. I'll have a number b times the quantity x minus c, and then afterwards plus d. Right? I know it's a little different, but this will help me keep track of things a little more easily. So remember this number here, the a, helps me keep track of the amplitude. All right, what's the distance from the middle of the wave to the top of the wave, or from the middle of the wave to the bottom? And our sine wave here, looks it's got the same orientation as our original sine wave. So it starts at a point and then goes up, then down, then up, same as the original sine wave. If it was the other way around, if it went down, then up, then down, that would be flipped over. So this would be negative. Right? This is going to be negative if flipped, right? But it's positive. It's going to stay positive here because we have the same orientation. Then this number b, remember that affects the period. The period of the function. Remember the period is 2 pi divided by this b. 2 pi divided by this b. Well, if the period of my function here is 2 pi, that means b is 1. So I'm going to have the number 1 there. This c in here, in the parentheses x minus c, this is telling me where the horizontal shift was. So see, instead of starting at x equals 0, starting at x equals negative pi over 2. So this is like I could put in this is where the horizontal shift comes into play. Horizontal shift, or start of the cycle. So this c is going to be this negative pi over 2, right, where the start of the cycle is. And then the d gives me the midline. Right, this gives me the vertical shift. Where's the midline? So that's here at y equals 2. So this is d. All I need now, so I've got b is 1 because the period is still 2 pi. The shift was negative pi over 2, left pi over 2, so I'm going to replace this c with negative pi. That'll make this x plus pi over 2. The d is 2, where the midline is, so this will be plus 2. And now I just need the amplitude, the distance from the middle to the top. That's just 1 unit. And again, it's not going to be negative because this isn't a flipped, right? It's just like the original sign, going up, then down, then up. So I'm going to have a be positive 1. So I've got everything I need. This graph that they gave me is the graph of the following function. Y equals 1 times the sine of 1 times x minus negative pi over 2, and then plus 2. And x minus negative pi over 2 is just, x plus pi over 2. Okay, but keep this in mind. All right, I'm going to make use of this always, and remember what the original sine looks like. Also remember what the original cosine looks like. All right, the original cosine starts at this point 0, 1, and then goes down and then up again and ends at 2 pi 1. Looks like that. This is one cycle of the cosine wave starting at the y-axis, starting at x equals 0. So if you remember what the original sine original cosine look like, and we'll fill in stuff like this where you have sine here or cosine, doesn't matter. But I'm filling in this a, b, c, and d depending on what kind of transformations are occurring. What's the amplitude? What's the period? Where is the cycle? Where am I starting the cycle? And what's the midline? And if you know those 4 things, you should be able to answer their questions about what the equation of a graph is. All right, so back here, amplitude was 1, and that's going to be a positive 1 because it's not flipped, times the sine of x plus pi over 2, right, or minus that negative pi over 2 where that cycle started. So minus negative pi over 2 would be plus pi over 2. And then after all that, plus the d, right, plus 2 where the midline was. Okay. Yeah, so you're paying attention to those four things. What's the amplitude? What's the period? What's the shift? Where am I starting the cycle instead of at x equals 0? Where is my cycle starting? And what's the midline? And if you know all four of those things, you should be able to write an equation for any wave, any sine or cosine wave. Alright, so this is the same kind of thing. Alright, so here, I notice they want a cosine this time. So again, they're giving us the beginning and the end of some cycle. Let's say this is one cycle here, it begins here at this point, ends at that point, and then you see how it starts repeating. Same thing over here, starts repeating. So this from this dot to this dot is one cycle. So what's the period? Well, we're going from pi over 3 to 7 pi over 3. That's 6 pi over 3. That's 2 pi again. So the value of the b, alright, so I'll write this up again. I'll write it up again and come back to you with some paper. Alright, so again, I've just written that one cycle that they gave us, from the point pi over 3, comma, negative 1.5, over here to 7 pi over 3, negative 1.5, and the lowest point had a value of negative 2.5, and the midline here is at negative 2. Right? I just drew the same picture. My labels on the axes are a little different because I don't know. I just decided to break up that period into quarters like I like doing. Again, if you saw my last video on part 2, I like breaking the period up into quarters. Alright, so again, we're trying to fill in this equation. Y equals some number times the cosine of, and then another number times the quantity x minus another number, and then after all that plus some other number. So a times the cosine of b times the quantity x minus c plus d, where a is related to the amplitude, b is related to the period, c is related to the horizontal shift, and d is related to vertical shift, right? Or the midline, right? The midline. So y equals negative 2 here is the midline. So that means d equals negative 2. Right, so I've got the d. I already said the period. Right, the length of this one cycle is 2 pi. So b equals 1. Because remember, the period is 2 pi divided by b. Well, 2 pi divided by what would be 2 pi? This is 2 pi divided by 1. Right? So b equals 1. D equals negative 2. Now for the c, I'm here at 0. Remember what original cosine looks like. I had it here. Starts at 0, right? My first cycle normally. This cycle starts at positive pi over 3. So c equals positive pi over 3. So I'm going to put that after the x minus. This will be x minus pi over 3. So I've got the c. A is the amplitude. Now again, you can take the highest value minus the lowest value and then subtract them. How far apart is 1.5 and 2.5? That's 1 unit. Then cut it in half. The amplitude is a half a unit. Right? 0.5 or 1/2. And would that be positive or negative? All right. Look at the orientation of the original cosine. See, the original cosine starts at the top of a hill and then goes down and up. So does this. This starts at the top of a hill and goes down and up. So it has the same orientation as plain old cosine. So there's no flip. Right? If there was a flip, I'd say that a was negative. Right? Make it negative half. If there's a flip in the orientation of the sine or the cosine, you're going to make that number in front a negative number. So the graph they gave me is y equals 1/2 or 0.5 times the cosine of 1 times x minus the starting point there, x minus pi over 3, and then plus negative 2, so minus 2. There's the equation for this particular graph. All right, just filling in a few things. Again, one more time I'll say it. You need to know the amplitude and if it's flipped or not. All right, because again, if it's flipped, that'll be negative. The amplitude, and if it's flipped, the period to help you find that b, where you're starting the first cycle from for the C, and then the midline for the D. So this was a let's put 0.5 times the cosine of, and then x minus pi over 3. And then afterwards plus negative 2, right? The midline was at negative 2. So plus negative 2. It looks funny, but that's the correct entry. Okay. All right, next we're going on the other objective, which is actually graphing them. And like I said, I'm going to be going over the same procedure I went over last video on section 8.1 part 2. Graphing with what I call the key value method. If you'd like, you can click on more instruction and graph your own. All right. And graph it the way they graph it. Now, I know you could go to a calculator, like I've got Desmos up here. If I pull here up here the Desmos graphing calculator, let me clear some of this out. This is desmos.com, free online graphing calculator if you want to use it. Or you could pull up your TI-84, 83 and use that as well. Just make sure you're in radians, right? All these are in radians when you're graphing, radian measure. And I could enter this, it was negative 3 times the sine, so y equals, negative 3 times the sine of x divided by 2, I believe. I'm already losing my thoughts here. Plus pi over 4 and then minus 2. Alright, plus, oops, get in there. Plus pi over 4, close parentheses, and then minus 2 after. And there's a picture of this graph. Got some key points labeled here. Negative 3 pi over 2, 1. Pi over 2, negative 5. 5 pi over 2, 1. And there's one cycle, but because this is a sine graph. And remember, our sine graph, when I look at it, when I look at the sine wave, I would like to look at it this way, right? So that where I'm starting from is on the midline. Now you can look at it from the top of a hill too, and the bottom of a valley. But when I look at sine graphs, I'd like to start my cycles to make the graph easier for me to draw. I'm going to start it at the midline. And for the cosine graphs, the cosine graph I'll start at the top of a hill or bottom of a valley, right? Because this starts at a peak. So sine, I would like to start, again, just to make my graphs easier. You don't have to do this, but just to make my graphs easier, I feel like it would be easier to start the sine waves at the middle, at the midline, and to start the cosine waves at one of the extremes, at one of the hills or valleys. Right, just based on the way original sine or original cosine looks. Right. So this is how this looks on a graphing calculator. Again, you'd see something similar. You can change the window up. You can just this is like a map here. You can just zoom in, zoom out, move it around, change settings and all that. All right. But again, I'm going to do this by hand. All right. So same steps I followed last video. So we're given y equals negative 3 times the sine of x divided by 2 plus pi over 4 and then minus 2 after. Alright. So the first thing I like to do is determine the phase shift and where I'm going to start drawing my first cycle. Now the way I determine that, so take this expression inside the trig function, inside the sine there. X divided by 2, plus pi over 4. And say, hey, when is that equal to 0? And you solve. This would be equal to 0 when x is negative pi over 2. Right, you would subtract pi over 4 and then multiply both sides by 2. And this value here is where I'm going to start drawing my first cycle. I'm going to start my first cycle, at x equals negative pi over 2. Right, then, what's the period? I'm going to determine the period. Now this x divided by 2 plus pi over 4 here, this is half x, right? Plus pi over 4, the number times x, the number being multiplied by x inside the trig function is a half. That's like the b from earlier, that b times x. So remember the period here, now the period for the original sine function is 2 pi, and that gets divided by this b, right, the number times the x. Technically it gets divided by the absolute value of b. The period should be a positive number, but this is a positive number. So 2 pi, divided by a half, that'd be 2 pi times 2, or 4 pi. All right, so the period is 4 pi. So when I go to graph one cycle, the point at the beginning of a cycle and the point at the end of that cycle should be 4 pi units apart. Okay. All right. Then, I've determined where I'm starting the first cycle. Just add the period on to tell me where the end of the first cycle is going to be. So I'm going to take negative pi over 2 from step 1 and add, 4 pi, add the period. Now you need a common denominator. This is negative pi over 2. This is 8 pi over 2. Put them together, you get positive 7 pi over 2. Okay, this value is where I'm going to end the first cycle, or the first wave that I draw. All right. And then, as I mentioned earlier, I'm going to take this cycle that starts at negative pi over 2 and ends at 7 pi over 2, and I'm going to break it up into quarters. Take a quarter of the period. So what's a quarter of the period? Now that's a quarter of 4 pi. Right, the period of this function is going to be 4 pi. Now a quarter of 4 pi is just pi. And this is a very important value, this quarter of the period. When I make this graph, this value is going to be the distance between every single key value I plug in. The distance between all the notches I make on the x-axis. Between every key value. Let me show you what I mean by making a table for the key values of this first cycle. Right. So here are the key values for the first cycle I'm going to draw. So you have x values, y values, outputs. Remember, I said I'm starting the first cycle that I draw at that negative pi over 2. And I'm going to end it at 7 pi over 2 by keep on adding pi. I start here and I keep adding this quarter period. So negative pi over 2, plus pi would be pi over 2. Plus pi again would be 3 pi over 2, because remember pi is the same as 2 pi over 2, right? Getting a common denominator. Add pi again would be 5 pi over 2. And then add pi one more time would be the end of my first cycle, 7 pi over 2. And if you're doing this correctly, this key value method for graphing trig functions, you should have for your first cycle, and for every cycle you create, 5 key values. And then lastly, I just plug these in and graph. Right, the reason these are called key values, just plug in and graph. Now, the reason these are called key values, the way I've set them up where everything's a quarter of the period apart, is when you plug these in to the function, you're going to get an angle inside the sine that's really easy to determine the sine of. It's going to be some multiple of 90 degrees, some multiple of pi over 2, and I will show you here. Right, and so when I plug in the first of these key values, when I plug in negative pi over 2 for x, we'll have negative 3 times the sine of and then you simplify what's inside here. Now when x is negative pi over 2, this would be 0, right? Because you have half of that is negative pi over 4 plus pi over 4 would be 0. And then you have minus 2 after. Now what is the sine of 0? That's just 0. This is negative 3 times 0 minus 2. So the output, when the input's negative pi over 2, is negative 2. And notice I'm starting at the midline, right? Remember, negative 2 here, this constant being added is the midline. I want to start my sine waves on the midline. And I'll start the cosine waves at either the top of a hill or bottom of a valley. Alright, the next one. When I plug in positive pi over 2, right, this is pi apart, a quarter of the period. Well, half of pi over 2 is pi over 4, plus pi over 4 would be 2 pi over 4, which reduces to pi over 2. So we have negative 3 times the sine of pi over 2. And notice these are 90 degrees, pi over 2 radians apart now. Then minus 2. Now that's negative 3 times 1, right? The sine of pi over 2 is 1. And then negative 3 times that minus 2 would be negative 5. Then I plug in the next one, x equals 3 pi over 2. Now after this first example, I'm just going to kind of say everything out loud because, with enough practice at this, you should be able to plug these in and get outputs pretty quickly. Much more quickly than I'm doing right now. So when I plug in 3 pi over 2 for x, well, half of 3 pi over 2 is 3 pi over 4, plus pi over 4 is 4 pi over 4, which is pi. So inside the sine function, when I plug in 3 pi over 2 for x, I'll have pi. Now the sine of pi is 0. So this is just negative 2 again. Now you could also use the amplitude for this now. See how the amplitude is going to be 3. And this is 3 below, come back, and then 3 above this would be 1. And I'll double check that here. When x equals 5 pi over 2, plug in 5 pi over 2. Half of 5 pi over 2 is 5 pi over 4. Plus pi over 4 would be 6 pi over 4, which reduces to 3 pi over 2. So this is negative 3 times the sine of 3 pi over 2. And then the sine of 3 pi over 2 is negative 1. Negative 3 times negative 1. Well, that's positive 3 minus 2 is positive 1, as I was saying. And then if you're doing everything correctly, when you plug in 7 pi over 2, you should get negative 2 again. Right? The value at the beginning of this chart and the end of this chart should be the same because they are one period apart. Remember, the period here is 4 pi. And these two values are 4 pi apart, so they should have the same values. They should have the same outputs. Alright, now I graph the thing. Alright, I'll make an xy coordinate plane. And I'll mark off these key values for at least this first cycle. So negative pi over 2, and then pi over 2, and just make sure all my notches are that distance apart. I'm going to try my best here. And then one more over here somewhere. There, let's say it's there. Okay. All right. So that's negative pi over 2, and then 3 pi over 2, 5 pi over 2, 7 pi over 2. And this should be enough for one cycle, and the outputs I'm seeing here are at positive 1, negative 2, and negative 5. And then we plot points and graph this thing, remembering that it's a sine function. It should be a wave shape. Negative pi over 2, negative 2. Pi over 2, negative 5. 3 pi over 2, negative 2. 5 pi over 2, 1. And 7 pi over 2, negative 2 again. And then you see the wave, right? Cup opening up, cup opening down. And that would continue on, right? This shape would be repeated over and over and over again for every 4 pi. And if you wanted more key values, you just keep adding or subtracting that quarter of the period. Keep adding and subtracting pi. So if I wanted like the next key value to the left, just keep subtracting pi or adding pi, that quarter of the period. If I subtract pi, I'm going to take this distance over here, but say it's like there, that'd be negative 3 pi over 2. And if I followed the wave, the output over here would be 1. That'd be the top of value, and then come back down. And you can go this way as well. Just keep adding pi. Keep adding that quarter of the period to get more and more key values. And if you want, you can plug them in. But really, you just need to follow this first cycle, right? From here to here, right? That was the first cycle. And that wavy line picture I just drew will repeat over and over and over again. Now on the website, in your assignment, this is one of these interactive deals, right? So you gotta read the instructions. Drag the black dot to shift your graph in the desired direction. Use the blue draggable dot to change the period, and then drag the orange dot to change the amplitude and/or reflect with respect to flip it over. All right. Again, I'll pull up my picture there, and I'm going to try to change this thing so it looks kind of like my picture. All right, at least draw that first cycle. Now notice the green. It says the green dots, right? The horizontal distance between the vertical dotted green lines correspond to one period, right? One cycle. So I'm going to shift this black dot here. Okay. Can I not move it up and down? Oh, yes, I can. Okay. So I'm going to try and move that to negative pi over 2. And then negative 2. And that's where I started the first cycle. There we go. Then this blue dot, I'm going to move to the other end at 7 pi over 2, negative 2, right? That was the end of the cycle. 7 pi over 2, negative 2. So 2 pi is 6 pi over 2. 9 pi over 4. There, 5 pi over 2. 7 pi over 2, negative 2. There it is. Right. So now the period is 4 pi. Right. This one cycle, the distance between these green dotted lines is 4 pi. So again, I put that black dot here at negative pi over 2, negative 2. I put the blue dot here at 7 pi over 2, negative 2. And now I just need to flip the thing and make sure I'm just going to move this yellow dot. See, the hill's not going up. It's going down. It's not going up. It's flipped. And this is the point pi over 2, negative 5. Right now it's at pi over 2, negative 1. I'm going to put it at pi over 2, negative 5. There we go. This is my picture. It looks a little different because it's a computer. It's a much better drawing than I have. But this is exactly where the points on my graph are. All right. So let me get rid of the paper here and submit this. Wonderful. Let me go through all that. All right, so probably got another one similar to this after. Yeah, more dragging dots. Right, so again, I'm gonna do this again. Right, I'm going to graph one cycle, one period's worth of this function, this cosine, and we'll compare it to the graph they're trying to make it, and then move points around so that they match the graph I'm drawing. All right, so here it is. We're asked to graph this cosine function. I'm going to go through this a little more quickly. It's the same steps I did in the previous example and the same steps I followed in the last video. So first I'm going to figure out where I'm going to start my drawing, where I'm going to start my first cycle. So I'm going to take this expression inside the cosine function here. set it equal to 0, and solve for x. So that would involve adding 3 pi over 8 and then multiplying both sides by 2. So x would be equal to 3 pi over 4. And you can double check. When I plug this in, half of 3 pi over 4 is 3 pi over 8 minus 3 pi over 8 is 0. So this is where I'm going to start the first cycle. Then, what's the period? Remember, it's 2 pi, right? For cosine and sine, it's normally 2 pi. But then that gets divided by the number multiplied by the x inside. Now this is, again, this is half x. So 2 pi divided by a half. And if it were negative, you divide by the positive, right? Keep the period positive. This is 4 pi again. All right, so the period is 4 pi. So from the start of my cycle to the end of my first cycle should be a distance of 4 pi radians, 4 pi units. Then I mark off where I'm going to end the first cycle. So I take 3 pi over 4, add to that 4 pi. Well, get a common denominator here. This would be 16 pi over 4, 3 pi over 4 plus 16 pi over 4, getting a common denominator. So that's 19 pi over 4. So here's where I'm going to end my first cycle. And then for all the distance, the distance between all my special values, my key values, the notches I make on my graph on the horizontal axis, I'm going to take a quarter of the period. What's a quarter of the period? I'm going to break the period up into 4 pieces. Well, just like last example, a quarter of the period is a quarter of 4 pi, or just pi. And again, this is huge. This is the difference between all those key values. All right, so I make a little table with the key values. Right, the beginning of my cycle is going to be 3/4 pi, 3 pi over 4. And then I'm just going to keep adding pi, which is 4 pi over 4. I get a common denominator. I'm going to keep adding pi until I reach this end here, right, the end of the first cycle. And you could keep going if you wanted, but again, I'm trying to draw one cycle of the graph, one part of the wave. So if I add pi, that'd be 7 pi over 4. Add pi again, that's 11 pi over 4. Add pi again, that's 15 pi over 4. And then add pi again, you get your 19 pi over 4. As I mentioned, would be the end of the first cycle. All right, now, this is where I'm going to have I'm going to say things probably pretty quickly here. You verify it for yourself. Plug these values in for x and simplify, right? Simplify the thing inside, take the cosine, multiply by -2, then add 2. So I already said earlier, when I plug in 3 pi over 4 for x, you're going to get 0 in here. Now the cosine of 0 is 1. And -2 times 1 is -2, plus 2 is 0. So input 3 pi over 4, output 0. Half of 7 pi over 4 is 7 pi over 8. Minus 3 pi over 8 would be 4 pi over 8, which is pi over 2. The cosine of pi over 2 is 0, times that plus that would be 2. Half of 11 pi over 4 is 11 pi over 8. Minus 3 pi over 8 would be 8 pi over 8, which is pi. The cosine of pi is -1. Times -2 would be 2, plus 2 is 4. And then I'm telling you it's going to be 2, then 0. And I'll leave that to you to verify that when you plug in 15 pi over 4 and 19 pi over 4, you'd get those outputs with this function. All right, so I make a graph. And again, start off somewhere. There's 3 pi over 4. It's a positive value. And then the distance between each of my notches is going to be pi. Right, so pi is a little bit more than that. So like I say here, so like go that distance of there, and then there's pi units. So there's 7 pi over 4. Then add another pi, 11 pi over 4, and then add another pi, 15 pi over 4, and then add another pi, 19 pi over 4. Right, again, this isn't perfect or anything, but my outputs are 0, 2, and 4 in this chart. So I got 3 pi over 4, 0, 7 pi over 4, 2, 11 pi over 4, 4, 15 pi over 4, 2, and 19 pi over 4 is 0. And remember, it's a wave. Cup opening up, cup opening down, cup opening up. Right? And the midline here is at 2. And it would continue on like this and like this, going on this way and that way forever. But this picture I just drew, from this point right here that I made really big to that point right there, is one cycle. And those are the points I'm going to move my dots to back here. All right, so here it is again. I'll pull up my picture. So I'm starting off here at the point 3 pi over 4 comma 0. So that's where I'm moving the black dot. All right. Why is it doing? All right, so this is unusual. All right, so it looks like the black dot is at the midline. Okay, so looks like the all right, so these black dots in my drawing are the bottoms of these valleys. So I'm going to move those. All right, so the looks like the yellow dot, I'll move to 3 pi over 4 comma 0. All right, so I'll move that up. Come on. All right, well this is annoying. Alright, so I guess if I was focusing on moving, if I want that yellow dot, the bottom of that one valley to be, I need to move the black dot to this point, which is at 3 pi over 4 comma 2. Alright, let's see if I move the black dot to 3 pi over 4. 6 pi over 8, that's 4 pi over 8, 5 pi over 8, there it is. 3 pi over 4, 2, there. Now you see this bottom, oh gosh, yeah, there it is, okay. So now you see this yellow dot here is at 3 pi over 4 comma 0 like I want. Now I just need to move this blue dot to the other end. I need that to be at the end of my cycle at 19 pi over 4 comma 0. So right now it's at 11 pi over 4. Now 19 pi over 4 is bigger than 4 pi. 18 pi over 4, 19 pi over 4. There it is, 19 pi over 4 comma 0. So you see the cycle I just drew? See, starting here at the bottom of this dip at 3 pi over 4 comma 0, like that point is. And then it goes through one cycle, and the end of the first cycle is at 19 pi over 4 comma 0, which you see in this picture. Looks like my drawing, only better, because it is a computer drawing, right? Alright, so I get my there, and looks like I graphed this nicely. Wonderful. Alright. So again, a couple more of these. Alright, and I'll do it again. Alright, so this is another one where I got to move the black dot, which is in the middle, so that the yellow dot and blue dot are in line with what I want. This is another cosine. Alright, so back to the paper. Now I'm going to really fly through this one, so pause things if you need to see. Alright, so here's the function I'm asked to graph. And first thing is I'm going to figure out where I need to start. So I take the expression inside, set it equal to 0. That'd be at negative pi over 4. Alright, if you subtract pi over 8 and then multiply by 2. So I'm going to start there. Next, the period. Same thing as 2 pi divided by a half, right? 2 pi divided, because of cosine. Cosine and sine have a period of 2 pi normally, but that's going to be changed by this transformation, this half x here. So I divide by a half, and it's again 4 pi. Right? Not every single example you see is going to have a period of 4 pi, trust me. But the period's 4 pi. So I'm starting there, and then where I'm going to, so I'll write that, start the cycle. Then I take negative pi over 4, add 4 pi. That'd be 16 pi over 4 minus pi over 4 would be 15 pi over 4. So here's where I'm going to end the first cycle. Then a quarter of the period, right? What's the distance between all the notches I draw, between all the key values on my graph? That would just be pi, right? Because again, the period was 4 pi. So a quarter of that is pi. All right, then I'm making a little chart. x values, y values, and starting at negative pi over 4, and I just keep adding pi, which is 4 pi over 4, right? Add pi, you got 3 pi over 4. Add pi, 7 pi over 4. Add pi, 11 pi over 4. And add pi, 15 pi over 4, right, which is where I said it was going to end. So again, 5 key values. Now I plug these in to this function. Right. Cosine, and when I plug this in, you'll have 0 in here. So cosine of 0 is 1 times negative 3 minus 1 would be negative 4. Plug in this, half of 3 pi over 4 is 3 pi over 8, plus pi over 8 would be 4 pi over 8, which would be pi over 2. Cosine of pi over 2 is 0, and then you have minus 1, minus 1. Right, then 7 pi over 4, half of that 7 pi over 8 plus pi over 8 is pi. Cosine of pi is negative 1, so 3 minus 1 is 2. And then negative 1, then negative 4 again, I promise. All right. Because you see it's going up and coming back down like the wave should with this negative sign in front of here, because this negative sign in front will flip the normal cosine. All right, then in graphing this, I'll say this is negative pi over 4, and then I have add pi, so it's negative 1 pi over 4, and then 1, 2, 3. Let's say that's 3 pi over 4 over there, 3 pi over 4. All right, so that's pi, and then another pi, and then another pi, and then another pi, and there's your 5 values. And this will be one cycle. The values showing up in my outputs: negative 4, negative 1, and positive 2. And I plot points based on that chart. Oops, not there. Not there, right here. So negative pi over 4, negative 4, 3 pi over 4, negative 1, 7 pi over 4, 2, 11 pi over 4, negative 1, and 15 pi over 4, negative 4, and yup. And that would continue on that way forever, that way forever. But there's one cycle from this point to that point. One full cycle of this cosine graph. All right, so again, I got to move this thing around. Now the midline is at negative 1, so that black dot I need to move to negative pi over 4, negative 1 on the computer. All right, so again, I'll pull my picture up. I got to move this black dot over to negative pi over 4. And then negative 1. There. And move this dot up a bit, or move it down. It needs to be at negative pi over 4, negative 4. Right? That's where my start of the cycle is. Negative pi over 4, negative 4. All right, and then the other one needs to be at 15 pi over 4, negative 4, and it is. So it's already done. The period is 4 pi, and it has an amplitude of 3, and phase shift to negative pi over 4, pi over 4 units to the left, and all that good stuff. So graph is perfect. But you see, if you practice this enough, you can get quick. And looks like I got one more to do. So I'm going to do it one more time. Geez, okay. This is another one with a half x. Well, they shouldn't all have half x like this. Right? No, you know that there's going to be other numbers times the x other than a half. All right, I don't know why it's always a half here. They should have a better variety of examples. All right, so this time I'm doing this. Y equals positive 3 times the cosine of half x minus pi over 4, and then plus 2. Alright, so I'm going to start at x equals pi over 2. Alright, just again, take this expression inside, set it equal to 0, and solve. The period is again 4 pi. Alright, it's 2 pi divided by a half. I'm going to end then at x equals, pi over 2 plus 4 pi. Well, that's 8 pi over 2, so 9 pi over 2 when you add them. A quarter of the period is again pi, so this will be the difference, the distance between all my notches, all my key values. Here's a chart starting at pi over 2, and then I just keep adding pi, which is 2 pi over 2, right? So 3 pi over 2, then 5 pi over 2, then 7 pi over 2, then 9 pi over 2 are the key values for my first cycle. And then I plug these in. And then I plug these into this function. Cosine of 0 is 1, 3 plus 2 is 5. Cosine of, when I put that in, I get the cosine of pi over 2 is 0, plus 2 is 2. Plug this in, you know, the cosine of pi is negative 1, negative 3 plus 2 is negative 1, and then 2, and then 5. Because it's falling down, then coming back up. All right. And then I plot these points. So I'll start here, pi over 2. So if that's pi over 2, let's say that's 1, 2, 3. Just pi. Keep adding pi. So that, that, and that, and that. All right. These aren't perfect. All right. I'm trying to rush this one. 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. Just labeling them. And then the outputs. There's 5. There's 2. There's negative 1. All right. So pi over 2, 5. 3 pi over 2. 2, 5 pi over 2, negative 1, 7 pi over 2, 2, and then 9 pi over 2, 5, and then you got your wave falling, rising, you know, cup down, cup up, cup down, and going that way forever, going that way forever. Repeating the same picture, right? This picture from this point to this point over and over again, this one cycle. Alright, so when I'm moving this stuff around, the middle point is at 2, so I need to move that black dot to the point pi over 2, 2, and have the hill be above, right, at pi over 2, 5. Right, so let's go here, pull my picture up. So I'm moving this black dot here to pi over 2, 2. There we go. Nope, come on. There, pi over 2, 2. And I like the top of the hill, though, to be at pi over 2, 5. And then this other one to be at 9 pi over 2, 5. Oh, that's 5 pi. There, 9 pi over 2, 5. And then the top of that hill is where I want it. The top of that hill is where I want it. One cycle's in there between pi over 2 and 9 pi over 2. Wonderful. Amplitude's correct, period's correct, all that good stuff. Alright, so yeah, you saw me in the last two examples I did rush, but really that's how quick they can be if you, practice more and more. Right. So I'd even recommend going back to your OpenStax book, section 8.1, and practicing extra exercises there, practicing making other graphs, and then go to Desmos or your calculator and make them there too, and then compare your drawing to the calculator drawing and make sure you're getting it correct. All right, and that should be it for this section. Those two objectives. Yes. No. There's. All right. So this one is. Oh yeah, I didn't finish the first objective. Ugh. Find the equation. Now this is you're given the graph. You have to find the equation. That was finding the A, B, C, and D. All right. So remember A. All right, so see, they're starting a cycle here at the bottom of a hill, bottom of a valley, and ending it over here at bottom. So we're going to call this a cosine. All right. Starting at tops of hills, bottoms of valleys, we'll call cosine, and starting in middle at midlines, we'll call sine. Now this is starting at the bottom and moving up. Remember, normal cosine starts at a top and moves down. So this, so for my amplitude, for the number in front, I'm going to put a negative number because this is flipped. Now the amplitude, see, this is going from the bottom is 1, the top is 3, so that's 2 units cut in half is 1. So I'm going to put negative 1 in front, right? And the only reason I made that negative was because it is flipped from the usual cosine. All right, then in here. What's the period? All right, you know what? I should probably write this out. All right, so here's a very, very rough drawing. And the midline here is at 2. And I'm trying to draw this, right? Y equals A times the cosine of, and then B times the quantity x minus C, and then plus D, right? Where A was the amplitude, which we saw was 1. And the absolute value of A is 1. But it is flipped. All right, again, normal cosine starts at the top of a hill and moving downward when you start a cycle. This is starting at the bottom of a valley and moving upward. So that's why I put -1 in for the A. Now the B is determined by the period, which is the length of this cycle. Now the period, this is -π/3 to π/6. That's -π/3, which is -2π/6 to 1π/6. That's 3π/6. That's π/2. The period is π/2, which is equal to what when you talk about 2π/b? Let's solve for b here. See, that b would have to be 4, wouldn't it? In order for, 2π divided by 4 is the same as π/2. So this b is 4. Times, and then x minus c. C is basically the phase shift. Where am I starting the cycle instead of at 0? So c is this -π/3 where the cycle is starting. So times x minus and then -π/3. And we'll distribute and simplify that. And then again, plus d. Oh, sorry, too many parentheses. Plus d, and d is the midline. Right? D is happening at y equals 2, plus 2. And then simplifying this would be negative cosine of 4 times the quantity x plus π/3, and then plus 2, and if we put the 4 back in here, distribute the 4, that'd be -1 times the cosine of 4x plus 4π/3. Alright, putting the 4 in there, and then plus 2, right? So this function here, y equals this, has that graph, the graph that they were given to us, right? So we're entering here, -1 there, like I said, and then inside the cosine, after distributing that 4, I had 4x plus 4π, can't just spell pi, 4π divided by 3, and then afterwards plus 2 for the midline. Okay, and then probably one more of these. I noticed that the objective was only like half done. Yeah, find the equation. Alright, so this one I'm just going to kind of say out loud. Now this is a plain old cosine, right? Starting typically where we start at the top of a hill and move down then up. That's usual cosine. So when I put the number out in front of the cosine, it'll be positive. Now what's the amplitude? Right, we're going from, looks like, the highest value is at -0.5. The lowest value is at -1.5. That's only 1 unit apart. Half of that is a half. So the amplitude is 0.5. I'm going to put 0.5 out in front. All right, the period, you're going from π/3 to 5π/6 for this cycle. That's 2π/6 to 5π/6. That's π/2 again, meaning that the value of b would have to be 4, just like last time. So I'd have 4 times the quantity x minus, and then where is this starting? π/3, right? So x minus π/3, and I close parentheses there. Now, really I should distribute the 4, and if I distribute the 4 to this x minus π/3, it'll be 4x minus 4π/3. So I'll do that. Let's get rid of the parentheses and make this 4π/3 and this 4x, right? So that's after distributing the 4. And then plus, where's the midline? The midline's at -1, so plus -1 at the end there, right? You should, and if with enough experience, you only saw me do a few of these, but you should be able to do that easily. All right. And then go through, and please read through the answer explanations when you're done with problems, and even if you especially if you get them wrong. And if you're still struggling, of course, look at more instruction, look at other videos that have been posted, all that stuff. Read the book, section 8.1 of your OpenStax book, and practice stuff there. All right, so hopefully this video, like the other videos this week, right? These were pretty long ones for section 8.1. Graphing takes a while to learn. So it also, takes a while to demonstrate, as you've seen in my part 1, part 2, and part 3 videos. But hopefully you can use these as a decent guide, to help you work through these problems when you work through this assignment on your own. All right. So, and of course, if you have any questions, let me know. And thank you very much for watching.